Bind analysis and formulating a tentative cut plan are for some the most rewarding part of meeting the objective of the OLEC process. In this discussion module, we're going to talk about binds in general, the types of cuts for a bind or combination of binds, and the use of wedges to control a bind. We will cover hazard tree scenarios in greater depth in the next discussion module, hazards and trail crew safety. The Forest Service defines a bind as the two major components of a bind are compression and tension. The directional pressures of compression and tension determine the sawing technique and procedure used to release them. Compression forces push towards each other. Tension forces pull away from each other. Compression and tension forces on a downed log are based on the force of gravity and how gravity interacts with a log. These forces are dynamic and will change during a saw cut. The Sawyer team goal is first to identify the forces at play and then plan a cut or cuts to safely release that energy. Determining the binds in a downed log can be the most technically challenging part of the OLEC process and the cut plan. But this also is the most rewarding part of participating in a saw team, building a plan based on the objective and then making it happen. Top bind is the result of gravity acting on the unsupported section of the log between two supporting bearing points. This is the most common downed log scenario. These compression and tension forces decrease as you get closer to a bearing point. The size of these forces depends upon the weight, size of the log, and the distance between the bearing points. Bottom bind is caused by gravity acting on the unsupported section of the log. Depending on the size, length, and condition of the fiber of this cantilevered log, there can be an amazing amount of energy in the cut. And the cut will be very dynamic. Prepare for a lot of movement. Also be wary of torsional binds on the log during the release cut. It might want to roll. In some situations, the binds may be what we call multiple severe binds and require considerable attention by the saw team. If physically possible, some sawyers will go well out of the trail corridor to make a cut just to release some energy in the bind at the trail corridor area, particularly at a bearing point. This type of bind and cut can cause a barber chair or alligator mouth release, some with a lot of energy. Be wary and always consult with more experienced sawyers if necessary. Side binds can be very challenging for a sawyer team. Often in a green log, there is a lot of hidden energy that can surprise a saw team. Many times, a cut must be planned well out of the trail corridor just to release some of that energy. Look for bearing points that indicate side bind. The energy is released on the tension side of the log, so cutting operations must be done on the compression side of the log. Establish safe escape routes and a safe area for the saw team. Cutting next to a bearing point allows for the controlled release of energy, and often a sawyer can stand behind a tree for safety. Did I say that side binds are often more complex and therefore dangerous than a simple top or bottom bind? Don't hesitate to consult with more experienced sawyers when severe side binds are involved. The weight of the log above the cutting area causes compressive forces acting on the length of the log. Be wary. These logs may want to roll or slide after the release cut. Now let's talk a bit about the types of cuts a sawyer can make in a log. These are the more common types of cuts a sawyer team will use. Straight cuts are perpendicular to the length of the log. They are very common cut for most log situations. Compound cuts are more technical, but can be very effective for controlling the cut piece during the release. Offset cuts are necessary to protect the saw during the release. They require a bit more skill from the saw team. These are the most common types of cuts for a Sawyer team. We will discuss some other types of cuts during the Forest Service certification course. Wedges are used to control the bind that is under compression. In other words, the bind wants to close, and wedges help to keep it open so the saw can move freely. A saw team should have a good variety of 6-inch and 10-inch wedges, certainly a minimum of 4 each, and that is dependent on the sizes of logs to be cut. Let's spend a little time with an overview of hazards and how they might impact the safety of a saw team. In this module, we will review hazards at the job site, an environmental assessment, and binds, and discuss how they collectively factor into the Sawyer team go, no-go decision process, with the understanding that these are all guidelines to assist the saw team lead and the saw team. Hazards can usually be mitigated when they are identified and understood. This is a good list for identifying common hazards at a job site. The OLEC process helps the saw team in an orderly approach for the identification and mitigation of hazards. As part of your initial situational awareness assessment, it's important to look up, look down, and look around for hazards that might impact the saw team. As you swamp out the work area, you will be able to see spring poles, pivot points, identify bearing points, and inspect the root wad. This will help to determine the cut sequence and how binds will change. This in turn will help you plan for the movement of the cut piece off the trail. It's important to establish the escape routes. All of this discussion will build the overall plan for the saw crew. Here's a good example of a very dangerous spring pole with a lot of energy locked into the bend. Notching in the inside center of the bend is the best practice to release that energy. Never cut one end or the other. For TKO, many of our work trails have fire-compromised snags and are a particular hazard we encounter. Most roots have been burned and can contribute to a tree fall at any time. In a classroom course, we will spend a lot of time on the go, no-go decision process as an interplay of job site complexity and the lead sawyer's qualifications. The previous list, when coupled with the OLEC methodology, helped to determine the job site complexity. Then the saw team lead has to determine if the overall objective is within their skill level, competency, and qualifications. This then becomes the basis for the go, no-go decision. Our WTA colleagues use a simple guide to quickly assess the complexity of the job site and objective. This log has a detached uphill root ball, and the log is on a 60-degree slope. There are several severe hazards here. For this saw team, mitigation was to cut a step in the hazard log. This is on the Wyeth Trail in the Columbia River Gorge. Hopefully this gave you some insight to the Crosscut Sawyer and Sawyer team world. In a formal classroom setting, we will discuss all of these aspects of participating on a crosscut saw team in greater detail. Come join us for some crosscut saw logout fun.